All right, now we're moving to three-factor medication analysis. So as you will know, and as you can see by the question, there's a lot more we need to find out. But again, it's just using the same dimensional analysis. Remember, we're finding out what the order is, what the given quantity, over what we're looking for. We're looking for what is on hand, and sometimes we need to do some other conversions to get our answer, because many times it's based on weight and other factors. So let's look at this. A patient's receiving dobutamine. Remember what that is, an adrenergic agonist. 250 milligrams in 50 mLs of D5W, 0.45 or 0.5% normal saline. Provider orders to titrate to a specific blood pressure. So the IV pump is set at 9 mLs per hour, but how many micrograms per kilogram per minute is the patient currently receiving? So he wants to make some specific parameters and wants us to titrate it to the desired blood pressure. And just so you know, D5W / 0.5 normal saline, that is actually one bag of fluid with dextrose and water and some salt in a normal saline bag, if you're not aware of that. So it's one bag, it's not two separate things. And the patient's receiving 250 milligrams of dobutamine and 50 mLs of this D5W. So there's a little 50 ml bag here and of 50 mLs of this D5W. And what also is in there is 250 milligrams of this dobutamine. And the pump is going right now at 9 mLs an hour. But we need to know how many micrograms per kilograms per minute the patient's receiving, because this is some very potent medication. All right, so let's just set it up like we would set up on any other drug calculation. So our given quantity, remember, or what the doctor ordered, was 9 mLs per hour. And remember, I like to circle or highlight things. And what's the wanted quantity? We want to find out. So the provider's saying, well, I want to know how many micrograms per kilogram per minute there are. So that is my wanted quantity per kilogram per minute. What else do I have on here, though? As we talked about here, we have this dobutamine, 250 ml. So that's the dose on hand that we have. I'm going to need that in order to calculate. What do I need? It looks like I need the patient's weight, because if I need to find out kilograms, I need to find out. I just will say the weight is 165 pounds. So as you can see now, if it's kilograms per minute, we need to do some more conversions. All right, so let's set up our problem here. There's a lot more steps to this. So let's just see. Let me just divide this up. I'm always running out of room here. We'll start up here. I'll try to write small. All right, so step one here. We have 9 mLs per hour. I always put the given quantity first and then what we're asking for. Your answer we're looking for is micrograms per kilogram per minute. All right, that's what we're asking for. Now what else are we going to put in? Now we need to start doing some conversions, which actually I'm going to just put 9 mLs over here per hour. Start doing some conversions. So next, I'm going to put our dose on hand. So we have this one done and that done, and now the dose on hand, 250 milligrams per 50 ml. I also, looks like I'm looking for micrograms per kilogram per minute. So right now I can cross out the mLs. Now I'm going to have milligrams per hour. I'm not even close to that, right? I need to get to micrograms per kilograms per minute. So the next step I'm going to do is I know that there is, I hate it when it does that, it goes to erase, 1,000 micrograms in 1 milligram. Remember those little conversions that was on the first video? If you haven't watched that, 1 milligram to microgram, you just move the decimal point over 3 spots and you get your 1,000. That's how I get to micrograms. So now I'm at micrograms. So I can now cross out this milligram. All right, so I have what I need up here, the 1,000. So this one's ready to go, but I don't think I'm done here because we need to do kilograms per minute. So I know 1 hour is 60 minutes. All right, so I got minutes taken care of. I can cross out this hour. But what else do I need? I need kilograms. So these are one of these handy dandy memorization things is 2.2. I know 2.2 pounds equals 1 kilogram. And I'm going to erase this because I'm going longer. 2.2 pounds is 1 kilogram. All right, so what do I have now? I'm stuck with pounds up here, also with micrograms. I can't have that. So how many pounds does this patient weigh? 165 pounds. And let's see, what else can I cross out here? Milligrams, kilograms, 2.2 pounds, 165 pounds. So I have kilograms. Yep, I can cross out this pound. Sorry, I'm losing my mind here. Kilograms per minute, micrograms per kilogram per minute. Okay, see how this took a lot longer. But now you have it set up because now we have all our conversions crossed out. So you're going to multiply 9, and actually you can take out the zeros here, times 25, times, you can actually cross out the 0 here. And you're going to get this answer, which is going to turn out to 49,500. I suggest you do this on your own. Over 4,950. And you divide these two. There it goes, turning to erase again. And your answer is going to be 10 micrograms per kilogram per minute. Okay. Again, I would recommend going through these. These take a lot longer to do, and you have to make sure you get your conversions right. Sometimes it takes a couple times or a couple calculator rechecks to make sure. Let's do this next one. 7 micrograms of amiodarone per kilogram per minute IV. The supply, it's 500 milligrams per 250 mLs of 0.9 normal saline. The patient weighs 80 kilograms, so now we need to calculate the mLs per hour on the IV pump. So the given quantity on this is 7 micrograms per kilogram per minute, and the wanted quantity is mLs per hour. We have dose on hand also, and we have a kilogram, so the patient weighs 80 kilograms. So I'm trying to get as much information. And I'm switching between inks. We have 80 kilograms. We've gotten this taken care of. And mLs per hour we're looking at, right? And what's the dose on hand? 500 milligrams in 250 mLs. Okay, so it just kind of helps me 80 kilograms. Extract the information I need for those of you that like to have things like me extracted and looked a little bit nicer, even though my handwriting's a mess. Okay, so let's set this up. We're going to do 7 micrograms here per kilogram per minute. Our answer we're looking for is mLs an hour, right? So I always put that last. All right, now we need to get from here to here. We don't have mLs per hour yet, so we need to do some conversions. So the next thing I have is the dose on hand, so it's going to go next, 250 mLs. In 500 milligrams. All right, I'm still not there yet. So now I can do some conversions. So how many, I need to convert these micrograms and milligrams. So I'm going to do 1 milligram equals 1,000 micrograms. So I can cross this out now, and I can cross this out now. I can cross this out now, and that out now. So I'm getting somewhere here. We're at mLs now over here. Not at hours, still at kilograms per minute. Okay, we need to do the weight, so let's put the weight in. So 80 kilograms. And why am I putting it on top? I'm putting it because I have kilograms down here. Remember, we're always doing like a multiplying across the numerator, and dividing with the denominator. So it's more like a cross multiplication type problem. So I can cross out kilogram here. Okay, and then the next portion we need to convert then to hours, because I don't have hours down here yet. So I do know that 60 minutes equals 1 hour. All right, so do I have it all set to go? So I have an hour down here, right? And now I can cross out minutes here. Oh, I can cross out the kilograms. So I have the hour and I have the mLs. Okay, so now we're going to multiply 7 times 250 times 80 times 60. And then I'm going to multiply your 500 times 1,000 times an hour. Because remember, you can remove some of these zeros too. So if you have 2 zeros here, you can move the 2 zeros there. But just to make it easy, you can just times or multiply it all and that's it. So I'm going to equal 8,400 times 500, or divided by 500. That's what I got for my answers. And that equals 16.8. And so what do we do? Remember, if it's above 5, if it's 5 or above, then you round up. If it's below 5, you round down. So it will be 17 mLs per hour. And that's it. So just remember, when we're doing dimensional analysis or figuring out what the answers are to these, many times we need to do unit conversions. And so this is where it comes in handy to either have your small little piece of paper handy that has your unit conversions on there, or understand how to make a unit conversion. So remember, with the metric system, you move the decimal points 3 places to the right if you're going from larger to smaller units, or you move your decimal point 3 places to the left for each incremental unit you're moving up. If you don't understand this, watch my first video. It'll show you how to do that. I would also take some time and memorize some of the dimensional or unit conversions, and that will definitely help.